Hi everyone, Mr. Markwick here. In today's video, I'm going to be showing you how to calculate future value annuities using the graphics calculator. Previously in some of my videos, we've looked at depositing a lump sum, so a large amount of money, and watching it grow, or calculating how much interest we earn on that lump sum investment through compound interest. With future value annuities, what we're going to be doing is we're actually going to be depositing or investing a small amount more regularly, in regular intervals. And this is more of a realistic sort of situation. So for example, you've got a job, you know that you can sort of save $500 a month. Every month you're going to be depositing $500 into an account, and you're going to watch that or calculate how much interest is earned on that over the period of a year, keeping in mind that on top of the compound interest, you're going to be depositing $500 every month for a year. So, you know, how much will you have at the end of that year, not only through the 12 lots of $500 that you've deposited each month for a year, but also how much compound interest you've earned over that 12-month period. So there's a few ways of looking at future value annuities. Today, we're going to be looking at future value annuities where we're starting with nothing. So there's no initial amount that's been invested. Let's just say we're just going to start by putting in, like I said, $500 every month. So let's go and have a look at our first example here. It says Lewis deposits $600 each year into an account that pays 6% per annum, interest compounded annually. Find the value of the account after 15 years and how much interest has been paid. So first of all, we need to work out our values for N, the number of compounding periods, the interest rate, present value, the payments per term, the future value, payments per year, and compounding periods per year. So, N, the number of compounding periods. It is compounded annually, okay, for 15 years. So the number of compounding periods is 15. The interest rate, 6%. The present value, because we're not actually starting with anything, is going to be 0. The payments per term, in this case, it's going to be 600. Now, we're putting in a minus 600 because it is money that we are paying into the account. The future value is actually what we're being asked to calculate. And payments per year is going to be 1. And compound periods per year, because it's compounded annually, will also be 1. So you go ahead and put those values into our graphics calculator, and it will tell us how much we'll have in the account after 15 years. So again, we head into the finance function there. Excuse me. And put in those values. So again, in F2, your calculator will be pretty similar to this, even though it may not be exactly the same. So N, as we said, was 15. Interest rate was 6%. The present value, as I said, we're starting with 0. Payments per term, again here, minus 600. Future values, what we're asking it to work out, P/Y and C/Y will both be 1. Once we've got all that information in, we press F5 and it will determine the future value after 15 years for us. So the future value, based on all that information, is $13,965.58. Again, try and round it to 2 decimal places because we're talking about money, and that refers to 58 cents. So 13,965 and 58 cents is the future value. The last part of that question says how much interest has been paid. To work that out for part B, you could do the future value into the 15 years, which is 13,965.58. Subtract the 15 lots of $600. Okay, and that will tell you how much interest you've earned. Obviously, you've put $600 into the account every year for 15 years. So that's not interest, that's how much you're depositing. The rest of the amount in the account is the interest that you've earned, okay? There is another way of doing it though, so you can put that straight in the calculator. I'm going to show you another way of doing that using a different function within your finance function. So within there, you then go down to F4, which is amortization. So if I click on that, it's actually got all the details I've already put in, okay? So I'm gonna set the years. So PM1 and PM2 are gonna be the number of years. So from the first year to the 15th year, based on 15 compounding periods, an interest rate of 6%, $600 being deposited every year. The final value, or the future value, being $13,965.58. How much interest did I earn in that time? And if I click here, so this is the sum of all the interest over those 15 years. It actually tells it, works it out for me, which is a really good feature to use. It's minus 4,965, or the amount of interest that I've actually earned is $4,965.58. Okay, so the amount of interest, or the answer to part B here is 4,000. Whoops, sorry guys. I'll zoom back in there a bit. Let's get that up here. So 4,965.58, which would give you the same answer here as well if you'd done that calculation, right? So good idea to understand how to use that amortization function within your calculator. It can save you a little bit of time when these calculations get a little bit more complex or complex, or a little bit longer. So just one thing you have to understand when you're using this is that the number of compounding periods that you're putting in here. So I'm talking about the first year inclusive up to the 15th year inclusive, all right? And maybe I'll show you an example of when, so like, let's do it for now. Let's say, for example, I wanted to work out how much interest was earned just in the last 3 years of this investment, right? So I want to know how much I earned in year 15, year 14, and years 13 of this investment. So because those are my 3 years, I'm going to put in PM1 as 13, and I'm going to keep PM2 as 15. Now, I know the difference between 15 and 13 is only 2, but these are inclusive of those years. So in years 13, years 14, and year 15, how much money or how much interest did I earn in those 3 years? Okay, so then if I press the sum of all the interest in those 3 years, F4, it will tell me that the interest earned in those last 3 years is $2,043.62 to the nearest cent. Okay, so a little bit of a hint there, or a little bit of a, I guess, something to be careful of when you're using that function to work out the sum of all the interest. Anyway, moving on to the second example here. Says guy wants to raise $25,000 in 6 years by making regular deposits into an account which pays 5.45% per annum, compounded monthly. How much will he need to deposit at the end of each month? So here we're actually asking it to calculate PMT for us. All right, we know that the number of compounding periods is going to be 6 times 12, 6 years compounded monthly, so 12 times per year. The interest rate is going to be 5.45%. The present value, again, is going to be 0. PMT is what we actually are asking it to calculate for us. The future value is actually given to us in this case, $25,000. And of course, the last thing, PY and CY will both be, in this case, 12, because there are 12 interest payments per year and 12 compounding periods per year. So this time I'm going to put all that information into my graphics calculator and ask it to calculate PMT for me. So if I go back into the compound interest function here again for me, and when I change that within that F2 function, it would actually change all the data in F4 for me. You'll notice that you don't have to re-put it in there. It already sort of transfers it across. So the number of compounding periods, and you can just put it in like this, 6 times 12, it does the working out for you. Of course, it's 72. The interest rate is 5.45%. 0.45%. Again, we're starting with $0 in the account. PMT is what we're actually asking it to work us out for us, so keep that at 0. The future value, we want it to be $25,000. Okay, now this is going to be a positive amount because that's how much is going to be available to us at the end. You know, that's something that we can withdraw at the end. So keep that future value as a positive. And P, Y, and CY will both be 12. Again, when I change PY to 12, automatically changes CY to 12 for me. So now I'm asking it to calculate payments per term for me. So here, F4, it tells me in order to achieve $25,000 in 6 years based on that interest rate, compounded monthly, I would need to deposit $294.32 every month. Okay, so PMT equals $294.32. Okay, similar process if you're working out, in this example, how long it will take. But there is a little bit of a trick with this one at the end because remember, N will be the value of, or the number of compounding periods, not necessarily the number of years. So let's go ahead and work out this one. So let's read the question first, perhaps. Lynn wishes to save $15,000 for a holiday. She's able to invest $400 at the end of each month in an account paying 6.15% per annum. Interest compounded monthly. How long will it take her to reach her target? So here we're actually asking the calculator to calculate N for us. The interest rate is given to us at 6.15%. The present value, again, is going to be 0. Okay, we're starting with nothing, so 0. PMT, in this case, is going to be minus 400. Again, really important you're putting in that minus. Get in the habit of that because you're depositing it, you're putting it into the account, so minus 400. The future value is going to be $15,000. That will be a positive amount. PY will be 12, and CY will also be 12 because we're talking about being compounded monthly here. Okay, so go ahead and put all that information into our graphics calculator, and it'll tell us the number of compounding periods needed to achieve that. So let's just keep N as 0 for now. I is 6.15%. Present value 0. PMT here minus 400. The future value we want it to reach 15,000. And PY and CY will both remain as 12. Here we are asking it to calculate, as I said, N. So here, F1, calculate N for us. Tells me the number of compounding periods in order to achieve $15,000 based on depositing $400 every month at 6.15%. Would need 34.39 compounding periods, and in this case the compounding periods are every month, so 34.39 months. Okay, now it's probably not a reasonable way to present your answer. It's more appropriate to give the number of years and months. So let's divide that by 12 to work out how many years that's going to be. So 34.39 divided by 12 is let's go to 2 decimal places, 2.87 years. Now remember, 0.87 of a year is not 8 months. Okay, so I'm going to convert that decimal part there into months. All right, so to do that, I'm just going to go 0.87 times by 12 because there are 12 months in a year. And it tells me that my answer is 10.44. And I'm going to round it up to the next month. Okay, you should always round up to the next month because at the end of 2 years and 10 months, I'm not going to quite have the $15,000 that we're looking for, but at the end of 2 years and 11 months, I will have that amount. All right, so let's round it up to 2 years and 11 months as my final answer. Okay, it's more appropriate to give your final solution in years and months rather than just 34.39 months. Okay, so convert that to years and months if we can. Just keep in mind that your decimal, when you divide that original answer by 12, will not give you the exact number of months. You'll need to convert that by multiplying that decimal amount by 12. Okay, so just be careful of that. In this case, it's by 12, obviously, because it's talking about months, but you may need to do times by 4 if you're talking about quarter years, okay, and working out how many months we're talking about there. Last example, again, pretty similar, that we're kind of, we've got enough information here. We're being asked to determine what the interest rate would be, but we know that the value of N, based on this, again, let's read it first. Shakira can pay $1,500 per quarter into an account where interest is compounded quarterly. What interest rate would be required so that she has $28,000 after 4 years? So she's 4 years and quarterly, so 4 times a year is my value of N. 4 times 4. Interest rate is actually what we're being asked to work out here. Present value, again, we're starting with nothing in the account. There's no initial investment. The payments per term, per quarter, in this case, is going to be minus 1,500 or minus 1,500. The future value we're looking for is $28,000. And PY and CY, in this case, are going to be 4 because we are compounding quarterly. Okay, so let's go ahead and put all that information into the calculator and ask it to tell us what the interest rate would be. Again, if we, make sure we're using our compound interest function here. N is going to be 4 times 4. The interest rate is what we're asking it to calculate, so let's just make that 0 for now. Present value remains a 0. PMT is going to be minus 1,500 here. The future value that we're building towards is 28,000, and PY and CY will both be 4, remember, because it's compounded quarterly. Once you've got all that in there, now you can ask it to calculate the interest rate you would need to achieve $28,000 based on depositing $1,500 per quarter. So F2 here, calculating the interest rate, it would be an interest rate of 8 point, and let's round it just to 1 decimal place, 8.1%. So interest rate needed would be 8.1%, and that's it. That's how we use the graphics calculator to determine the value of future annuities, or based on a future value, how to calculate payments per term, the number of compounding periods or the amount of time, or the interest rate. Okay, so hopefully that helps. I know that's a lot of examples, but yeah, hopefully it helps. And thanks again for watching.